Swayam Prabha. Digital India. Educated India.
Okay, in the last class, we were looking at subjective objective evaluation. We'll continue this topic. This is probably one of the most important topics, especially for people who design vehicles. They want to understand how to satisfy the driver. In other words, that is what we call as subjective evaluation. Usually there is a jury of drivers, 6-7 people, who conduct a number of maneuvers and then answer questions in terms of ratings. For example, there can be a 1 to 7 rating for a question, 1 being bad and 7 being the best, and so on. Now, that's what we call a subjective rating. Objective is, as I told you before, it is the characteristics of the vehicle. For example, 4 of the objective metrics, which we called as memorometric, was already introduced to you. And the most important thing for a designer is to correlate between the subjective evaluation of the drivers with the objective metrics. It's not a very easy task, very difficult task. A number of papers are available on this particular issue. As I told you in the last class, I'm going to take some of the references which give clarity to this subject. Yes, there are others which have appeared recently. So we will concentrate on these references. Though we have done some work on this, and because of some proprietariness, we are not able to project all the results. But we will concentrate on published literature in order to understand this topic. Just to summarize what we did, understand that we were essentially subjective evaluation. In subjective evaluation, we are concentrating on how steering is given and how vehicle is going to behave to that steering input. Okay. Now, that's the most important thing. Now, the steering also involves, the steering input also involves how the steering is going to get a feedback from the vehicle due to certain maneuvers which we are going to do. Already we have seen this. We said that straightability, as the vehicle goes straight on a road, what are the things that we should look for in a vehicle. We were looking at steerability in the sense that how does the vehicle behave when you want to steer a vehicle. So in terms of agility, in other words, how much of steering angle you have to give in order that vehicle is going to listen to you. Precision, are able to follow a path with precision with the steering angles which you feel should be given. In other words, what is the feedback that you get from the vehicle, and comfort. Is the steering torque that you apply is very high or very low, and so on. So these are the 3 things that are very important as far as the steerability is concerned. We had already seen on-center feel. We had seen steering response. We talked about, you remember that we talked about the time delay and so on. And then we had talked about steering linearity, how much linear or non-linear is the input as the path changes. We were looking at what we called as steering precision. Okay, steering precision is actually a subjective evaluation of the path that is followed. How much of steering input I have to give, or how precisely is the path that is followed as I give the steering input. So that is yes, again a subjective evaluation of the path to be followed. Then we have the steering angle. Okay, this again is a subjective evaluation of input versus output. Say for example, you can draw. So you give a path, a graph between time and the steering angle. right? For example, the steering angle, of course you're going to take some time to give the steering angle. Let's say that that's the steering angle you give, okay? So you steer the vehicle to go at a particular path. Now, if that is the case, you can draw, okay, another graph between steering gain versus time. Okay, in other words, how much, since we are talking right now about steering angle, how much the vehicle is turning, okay, because of the steering angle with respect to time that you have given. Say it can be, there can be two graphs. One, say, let's say that one graph is like this, okay, the other graph is like this. Please note that when the steering gain is low, you have to give more steering, right? So this may be due to two tires, say tire A and tire B, two different tires, okay? Now, this is where subjective evaluation comes into picture. If you look at tire B, for example, it responds quickly to the gain, in other words, to the steering input that you give, okay? It realizes the steering input and quickly gets that gain that is required, okay, or the what we call as hand wheel to road wheel. The road wheel quickly raises, and then the input is realized. But the gain stops. In other words, the gain is a constant, which means that you have to give. Please note, gain is a ratio, and so you have to give more steering in order to achieve what you want, the path you want, right? So race time is high, but lot more steering has to be given. But on the other hand, tire B, the race time is low, but the amount of steering you have to give is less, okay? So this is what is realized, or this is what we call as subjective evaluation. How does the driver feel, or when does the driver feel comfortable with tire A or tire B, okay? This is what we feel, or what we say as subjective evaluation. Yeah, then we have what is called as the steering effort. In steering effort, you talk about the steering torque that you have to give. Amount of torque that you have to give is steering effort. Returnability, we saw that when I leave the steering, how fast time versus the steering angle. So how fast the steering comes back to where I left, right? So that is the returnability. So it returns to its original position. One of the most important things, so just go back. So here we are talking, all these things we are talking about is the steering and its effect on the vehicle, okay? So that's what we call as steerability, ability to steer. That's what we call as steerability, term used by Jem. Then we have what is called controllability. Okay, am I able to control the vehicle? And controllability comes especially at limit driving. It doesn't come on a very ordinary driving at 30 kilometers or 40 kilometers per hour in the city roads. So when we talk about controllability, we are talking about the limit driving, at limits. So with the grip, we are going to lose the grip, what's going to happen? Okay, this is what we are looking at. So in controllability, one of the first things that people today look at is what is called as balance FARA. Balance between the front axle grip and rear axle grip. Actually, when they talk about, this is a common terminology that's used. When they talk about balance between the front axle grip and rear axle grip, actually what they mean is the slip angle that is developed between the front axle and the rear axle. Though this term grip is loosely used, it's actually the force generated, or in other words, it is the slip angle that is created, okay, between the front and the rear. That's what we call as balance FARA. It depends upon, of course, on the characteristics of the front tire and the rear. So this to a great extent is a tire characteristics, which you can see this in many of the websites of the tire manufacturers, where they will talk about balance FARA, and usually it's talked in a scale, okay, or termed in terms of a scale. Right. So in other words, balance FARA is a measure of a transient oversteer or a transient understeer. We already talked about transient oversteer and transient understeer. Remember that when I'm going to take a turn, okay, I'm going to take a turn, I'm in a transient situation, and we had talked about usually whatever analysis we had done with respect to K was on steady state. So transient oversteer and transient understeer is when I enter a turn, when I power on or power off, okay, or accelerate. In other words, I accelerate or brake and so on. Please understand that there's again a confusion in the literature on braking, acceleration, power on, power off. Okay, these are rather power off and power on. In other words, we are looking at the vehicle's behavior in deceleration. It doesn't matter whether you are applying a brake in order to decelerate a vehicle or taking a pedal off the accelerator. Okay, taking the pedal off the accelerator is as much a braking as you apply brakes, right? Or in other words, power you don't give, power off is also braking. So usually, I would say that they are synonymous. That you take your pedal, your leg off the accelerator pedal is braking. Okay, so both of them, it's very important how the vehicle behaves in both these conditions. Why? As we had said before, whenever there is a load transfer, there is going to be a change in the slip angles. We saw that whenever the vehicle rolls, there is a change in the slip angle. In the same fashion, whenever there is a whenever there is a pitch, or in other words, whenever there is a transfer of load between the front and the rear, again I am going to have a difference in alpha F and alpha R. So whenever there is a transfer like that, alpha F, alpha R gets affected, and hence, okay, I get into a variation in the oversteer or understeer characteristics of the vehicle. Okay, so this is what is tested. This is what is tested when what happens when I power on and power off in a turn, whether the vehicle is going to become, how much it's going to become understeer or oversteer because of this transfer of power. Clear? Okay. Yes.
So won't there be a difference between the deceleration and the when you lift your leg off the accelerator and the braking?
I agree, because yes, I agree with you. I fully agree with you that brake system characteristics become important, and the rate at which it's braking is important. No doubt about it. Okay, it's a good question, good observation. But from a vehicle dynamics point of view, okay, I am looking at deceleration. So when I take my leg off this pedal, accelerator, automatically the vehicle speed comes down. That means, in other words, it is decelerating. Right? This is what I meant. Of course, deceleration or power off, okay, is no substitute for braking. There are other issues, because the intensity of deceleration also is different. But I just wanted to tell you that the behavior is similar. In other words, you can look at the behavior from both this perspective. Right. Okay. So usually when we say controllability, we are looking at the limit of the grips. I'm going to go a bit fast in this. In other words, we are looking at the stability of the vehicle at the limits. At the limits, I'm going to lose the grip, okay, or I've almost lost the grip, or I've lost the grip. How does my vehicle behave? This is the condition, at the limit conditions. The first thing under these conditions that you look at is what is called as yaw stability. So look at the slide. What are the things that we are looking at? So the first thing that we are looking at is yaw stability. What is meant by yaw stability? So the vehicle at the at this limiting conditions would actually yaw. Okay, this is because, I mean, there are a number of design reasons. Maybe this is because of the lateral compliance differences and so on. Okay, so the vehicle would yaw. The vehicle would be like this, then would be like this, then would be like this, and so on. Okay, so the vehicle yaw, as the vehicle yaws, what also becomes important is yaw damping. Okay, how much are you, is it going to go, it's going to be difficult to control the vehicle as it yaws. Okay, does it yaw? How much it yaws, and how difficult it is to control the vehicle. How does the yaw damping bring it back? Okay, bring back the oscillation to a steady condition and so on, is what we mean by yaw stability. Okay, so that's the oscillation around yaw, right? The other thing is what we call as rear axle stability, which means that it is the, if this is the vehicle, okay, so how much, so the actually it goes, you know, this slips up and down like that. So it's a straight line where the rear wags the tail. Okay, so that is rear axle stability. Again, it's a question of oscillation, okay, about the rear axle. Braking stability, sorry, roll stability. How much, as I take a turn, okay, the vehicle rolls, right? And this is slightly different from rollover stability, where we are looking at the propensity of the vehicle to roll over. Okay, this is a very severe test, usually done with steering robo. There are standards for this and so on. So roll stability is what does the driver perceive as the roll, and rollover is that the vehicle just rolls over. Then we are talking about braking stability. That means that you go straight, brake the vehicle, okay, how much of attitude of the vehicle I lose. Is it braking straight and standing there as I go, or does it move and so on. Then bump steer, the change in the toe as you go over a bump. Okay, this all of you who drive would have felt it in your vehicle. As you go over a bump, the steering steers and you have to hold the steering. And so what is the steering, that input that is given without your effort due to bump? You know, this is bump steer. So these are some of the things that you have to look at. So in a nutshell, when you test a vehicle, you look at how the vehicle behaves in a straight line when you go straight, how when you give a steering input, or what's the effect of the steering, and how the vehicle can be controlled. So these are the three things that
when you say you study controllability at the limits, you look at how controllable the vehicle is when it's at the limit of, say, yaw stability.
No, at the limit means I'm talking about the grip. Okay, at very high speeds when you take a turn and so on. Okay, we are not looking at, see, this goes with the limit of handling of the vehicle. Okay, we are not talking about these things at very low speeds. That's what I mean. Okay, under normal 40 kilometers per hour conditions of operation. Okay, that's what I said, that controllability at the limit. So what are the things that you do in the subjective test? Yeah.
So when we talk about yaw stability, there are cases when the driver won't be able to steer.
Yeah, of course. That is what is subjective rating. So how much the driver is, in one case, there may be a yaw of the vehicle and the vehicle may come back. Okay, in another case it may go out of control. He may feel very uncomfortable. So these are the feeling, you know, that's what we call a subjective rating.
No, sir, there are cases when the vehicle just plunge forward without the driver being able to steer it either way, right? It will just keep going straight without the driver having any.
Yes. See, see, that's true. That's what we are calling as the subjective evaluation. When we say about subjective evaluation at the limit, it's not that the driver has lost complete control, it's all gone, and what happens? No. Okay. What we call at this point, when I reach a limit, that additional input that is given, how does it behave? So the additional steering effort at the limit is what we are looking at. It is not that I've lost control. Okay. For example, if you look at grip, okay, grip is again a loosely used term. It's just for a force that grip is used. For example, you know that alpha versus Fy force, right? If you know that it's going to reach a limit and it can come down, or it will come down. Okay, so this is what we call as unstable region. But a tire need not have a very sharp unstable region. It can be quite flat. Okay, in which case the controllability of this tire, or at the limit, or the grip as we call it, okay, is better than this. Okay, so what are we trying to do when there is a change? This is exactly next half an hour. That's what we're going to see. When there is a change in the characteristics of the vehicle, okay, how does the driver perceive? Okay, just wait for some time and we will look at all these things. So in other words, quickly summarizing this, we are going to look at straight ahead, okay, free steering, free steering. I'm not giving an input. Fixed steering, I'm going to hold. I'm going to look at the torque or the feel in my hand. Power on and off, okay, and braking. We have introduced braking because a friend here said that yes, off and braking are different. Okay, so we have introduced braking. Steering, on center steering, we already saw on center steering. Off center steering, when the steering is not at the center, how does it behave? Progressive steering, this we called as linearity as a increase. Limit grip steering is what we have been talking about. And flick steering, when I just flick the steering, what is returnability? So that's what is given by flick steering. So we give a number of steering input when the steering is straight or when the steering is off center, away from the center. This is what we are looking at. We are also going to look at the vehicle during lane changing, that is single lane change. So in other words, the vehicle goes straight and then does a single lane change, or what is called as double lane change. So you go straight, due to some reason, you have to take a sudden severe double lane change. Okay, because of some obstacle here, okay, you have to do a double lane change. So this is what we call as lane changing. Cornering, circuit driving is very important. There is a circuit, and how do you travel in that circuit? Next time when you watch this Formula 1 car racing, you look at how actually drivers drive their vehicle. Very, very important. For example, if you let's say that there is a sharp corner like this. There are a number of things the driver has to do in order to efficiently, I say efficiently, it means the least time with least risk and so on. They have to take a turn. They have to, what is that they have to do? They have to actually start braking. They have to start braking. Okay? At what distance are they going to brake? Okay? How are they going to hold the pressure of the brake? Okay? Then, where do they take the turn? What do they do is, what usually it's called as apex hitting. So they won't go like that. So they would go like this. So they would hit the apex and go. Okay? In other words, as far as possible, these drivers will not take a large or a small curvature of this, or small, large curvature or small radius. They won't take it. As far as possible, they would go like this, and you would always see that in any of these formula cars, racing cars, they would go out and come down. Okay, you would see next time when you see that. That's because they want to hit the apex. Okay, brake, hit the apex, and then power on. As they come out of the corner, there will be power on. So there will be a power off, power on, okay, and then get into the straight lane. So it's very important that one understands. This is what we meant by cornering. Okay, so what happens when I power on or power off in a turn? Okay, and what happens if I brake in a turn? Okay, and I hope there is no rollover propensity. We'll talk about rollover in the next class, but this is very important, right? And we're not going to talk about ride now. Ride is what is called as a primary, not drive, ride. Primary ride, this is a mistake, this ride and secondary ride and impact ride. Okay, these are the three things. That depends upon the frequencies. We'll talk about that later. So, with this subjective rating, Krolla and his group, okay, they did, the University of Leeds, they did a number of tests. The whole idea is to understand what are the questions that you have to ask the driver. Okay, what are the, in other words, what are these, or what are the questions which are related to certain metrics, okay, of the car, right? And what should be the optimum range of this metrics. So this is a sort of an objective of this whole study. Okay, so what's more important, what's very important is what are the type of questions that you have to ask. So in order to do that, what they did was a very interesting, very elaborate study done with help of Myra. So you would see that they changed 8 vehicle parameters. They changed front tires, rear tires, front damping, rear damping, front roll stiffness, rear roll stiffness, yaw inertia and bump steer. All these things they changed in the vehicle. Okay, so they get different, 16 configurations, 8 vehicle parameters, they changed it and they got 16 configurations. In other words, they had 16 vehicles with various parameters, okay, these are the parameters that they changed. Then they did a test, okay, what is called a step steer test. It's a J-turn test. They give a steering, hold the steering. Then they did an impulse test, and then a steering pad. They went around and so on. So ultimately, they wanted to know whether it is possible to relate the subjective question. For example, if there is a question like ease with which line is held in smooth road cornering. Okay, if this is a question, they wanted to know whether this can be related to metrics like lateral acceleration gain at 0.4 hertz, yaw rate gain at 0.4 hertz, and yaw rate phase, sorry, this is spelling mistake again, at 0.4 hertz. So in other words, they wanted to relate the metric, which is a vehicle characteristics, with a question answer. Right? Is that clear? Any questions? Right. Now, the first thing you may ask is, what happened? We have left that Memuro model in the air. What is the subjective objective evaluation of Memuro model? Where do we stand? Very important question. This is the first question that was answered. Why is Memuro model important? Because there are only 4 parameters. You see that in this study the parameters increase. 4 parameters are easy to study. Okay? So what happens is that subjective evaluation correlate well with these 4 metrics? That's the first question, right? Okay, we'll look at.
And what is the process of actually coming up with a formula?
Yes, there is a whole set of statistical techniques that they had used. Okay, what is called as regression analysis and so on. Okay, we're not going into the details of it. I've given you the reference. Look at the reference, very nicely written. Okay, they call this as ridge regression. Right. So you can look at the reference, how they came up with. Ultimately, did they come up with this? And what is the driver? See, one of the major problems here is that they had a number of drivers. I remember right, 7 drivers. So the drivers had to agree. Okay, there was a substantial difference between the drivers. Okay, their inputs, because it is subjective rating. The drivers. That's why we have 7 drivers, and if the group is not well behaved, then there will be a difference between drivers themselves. One guy would say that ease with which line is held in a road cornering, this is again in a scale of say 1 to 7. He may give a rating of 3, another can give a rating of 5, okay, and the average may be 4, but the range may be very large, okay, and so on. Right? So there has to be a number of statistical measures that has to be introduced, given in the thesis.
But in the objective evaluation, we are doing away with all that. We are replacing them with proper parameters.
Yeah, exactly. That's what I'm going to see now. But does it have? Subjective evaluation is, as I said, is the ultimate, because whatever be the objective numbers, okay, you should feel that the car is good. That's what we call subjective evaluation. So in objective evaluation, we had 4 nice metrics. Do they really correlate with the rating by a driver? Okay, that's what we are looking at. For example, we said that the memororhombus is bigger, better. Is it really better? Can I get some cars and drive it with various memorometrics, various memororhombus, and say what you are doing? That's what is done here. So I have now 16 cars. What Memuro, for example, did was to take 20 Japanese cars and showed that these 20 Japanese cars had really a good correlation. The handling of these 20 cars had a good correlation with those 4 metrics. This is what he said. But this study here again wants to confirm whether that really works, right? So that's the interesting part of the study. Do you understand? Any questions? Yes.
So we consider that bigger the rhombus, better the car.
Yeah.
Then why are we having negative signs?
Exactly. So is that true? That's what I'm telling. Just wait for some time. Okay. Then I'll take the questions.
Sir, what is steering pad test?
So you have a steering pad in which you give a constant steering and go in a circle. Okay. Just go like that. That's a steering pad where there's a circular path which you follow. Okay. So these are the things we had already seen, that steady state turning, power on, power off, sudden braking, transient cornering. These are the subjective questions. Subjective questions were based on these things. We've seen this list already. Okay. Now comes the interesting part. The first thing he did was to check whether this Memuro model, okay, which is memororhombus, is good to give us a clue about driving. Okay. So remember that there were cars tested by Memuro, and that's there in that red, the red line indicates the range. In other words, between the 2 red blocks or red lines, say for example, all the Japanese cars which was tested by Memuro were between those 2 lines. This is the least and that is the biggest. Okay. So all these Japanese cars were between those 2 red boundaries, right? And when Chen, who did his PhD in this group, and Ash, when they got these cars tested for the memororhombus, their memororhombus, which is depicted in that blue, were between this boundary and this boundary. Okay, the very first thing that you see here is that the Japanese car had more understeer characteristics. Okay, so when I go to the right, that side, more understeer characteristics when compared to what was tested by the Leeds group, which had more oversteer characteristics. Okay, see the complete difference. Okay, then the next question you would ask is, see, these cars were, an experimental car. These guys were doing their PhD, so they had experimental cars. Okay, so their experimental cars were oversteer. Okay, the Japanese cars you say are understeered cars. Okay, what about European cars, for example? Okay. How much are they understeer or oversteer? Where do the actual European cars fall in this Memuro model? Okay, in other words, practically where do they stand? Interesting, they did that. So this is where, okay, the 2 cars fall between what is being done by Chen and the European cars. And before that, let's compare that. So this is what is the difference between the European cars and the Japanese cars. Okay, the range of the European cars were much less, okay, what has been tested than the Japanese car. In other words, what it simply means is that what the experiment that they did, the Chen and as their experimental car, even when compared to the European cars, had much more oversteer characteristics.
Both are similar in price.
No, 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 no. See, this is between the Japanese car and their car. Okay, they had oversteer and Japanese car had understeer characteristics. The European cars do not have that kind of understeer characteristics like the Japanese cars which were tested. Okay, but they still do not have, sort of, it's more towards the neutral steer. They do not have as much oversteer characteristics as was tested by this group. Okay, so clearly oversteer characteristics of the cars tested were much more for the study. Okay. Now, so they asked these questions. What are the questions for which there was a correlation? Okay, do you understand these graphs? Any questions?
Why is it different from Japan to Europe to?
That's how I mean,
No, why
that's
should
the
one
design.
country prefer
This is not a question of country. There's no generally tested, Japanese cars have that kind of understeer characteristics. Okay, that's a philosophy, right? The more important question is which we're going to ask is, what makes them like this? What are the characteristics of the car which makes the mirror rhombus like that? Do you understand? So this is what has been observed when we take up, I think about 6, 7 the European cars, and then they test it. They take 20 Japanese car and test it. Okay, what is the difference between the two? It's this.
But that would have been put into them by their manufacturers, right? There should have been some logic behind it.
Yes, this was put by the manufacturer. That's why one car is different from the other. So maybe you can say that the understeer characteristics of Japanese car is more, which means that much safer, especially when you drive fast and so on, right? So it's a question of philosophy of the car designers. Okay, so that's why what we are going to do, we're going to answer your question by looking at an optimized car. Okay, let me not go that side, let me not go this side. Please understand that this is theory, this is objective. Okay, the more important question you should be asking is, do people like Japanese cars or do people like European cars? Okay, we are live, so still, I don't want to answer that question. Okay, but which car is better from a subjective evaluation? That's more important question, right? So this is an objective evaluation. Right? I'm not going to answer that question. I'm not going to talk for one car or the other. Okay, that's not my intention. I'm saying that ultimately that's what you should be asking.
Which car is better will also depend on who's driving the car.
No, that's exactly the point. Okay, that is why we have expert drivers for subjective evaluation. It's not a question of who is driving. Okay, if you are driving, when we talk about subjective evaluation, that's why I repeatedly said that we are not driving at 40 kilometers per hour in our Chennai roads. That's not the issue. Okay, we are talking about driving at the limits. We are talking about, that's why I gave all those conditions here. So it's not a question of who is driving. Okay, so when we talk about subjective evaluation, we are talking about expert drivers. We are not talking about novice drivers. Okay, drivers who understand cars, who've been doing this for a long time.
But it's our comfort that matters in the end. Right? The customer who is a novice.
Absolutely, but it is usually felt that if there is an expert driver who feels that it is good, so that is why you choose an expert driver, okay, such a fashion that you test a car and he tests a car, it's the same. The feel is the same. Of course, you are free to choose whatever car you want. I am not advocating for you to buy this car or that car. You go to a showroom, get a car, and that's why you have cars for test drive, and you buy a car. That's your will and your pleasure and your money. It doesn't matter. Okay, we are talking about a subjective evaluation by an expert driver. Yeah, let's go ahead.
When we got this plot, we made a number of assumptions, right? That doesn't cover all our subjective questions.
Exactly. That is what I'm going to come to. So can we wait till I finish? Then you ask questions. I understand. I understand there are a lot of questions. Can you just wait? I'm going to answer all your questions. Okay, or these guys have answered all your questions. So wait, right. So the first thing is whether the drivers felt that this Munro rhombus, as it expands, okay, the car becomes better. There was a small, I would say, error in what they had said. Munro in his paper, in fact, very clearly said, I have this, I think I have the paper here, very clearly states that the phase angle phi right is better. Okay, so in fact, you would see that I'm just reading that statement. The right axis phi denotes following controllability. The smaller, that in other words, to the right is better. Smaller is not by magnitude, it's not minus 80 is smaller than 0, that's fine. But he has very clearly said the smaller, that means to the right, is better. Okay? But there's a small confusion in what Chen and Ash had said and what has been said in this paper by Munro. Okay? So first thing is that whether the cars tested and the driver's input, how did it correlate with expanding the Munro rhombus? That's the first question, right? That's very interesting. Okay. Now, this is what happened. The red ones are by Munro. As you move away like that from the center, okay, they agreed. The blue ones were by the Chen's group. Okay. In other words, there was a small difference. There is a difference between what has been said by Chen. One second, just I'll just give you the. I hope I have given you the reference. Yes. If you want, you can also look at this reference, Subjective Objective Assessment of Vehicle Handling and Performance by Krolla et al. in Seoul 2000, FISITA, World Automotive Congress. I mean, where also you can see what I am talking to you about. Okay, that's the reference. Okay, now you can look at that. This is so there is a difference. Now, why is there difference? In other words, is Munro wrong in saying this? That's the question. Is it that when he said that I want steady state gain to increase in order that the car should behave better, was contracted by saying that by this group that it has to be less? Is there a controversy or is there a difference? No. The most interesting fact that comes out is that that's why I had presented some time back. The type of characteristics of the car tested by this group is more oversteer. Okay? But the cars tested by these guys, I repeatedly said, by Japanese is understeer. In other words, the sentence is that it is not that there is a monotonic increase, okay, of these parameters. It simply means that there is a range, okay, an optimum range which would give you the best performance. Okay? So if you want to design a car, it should be an optimized. It's not that I keep on increasing the Munro rhombus. From this study, that's what you get. Okay? It would become better. It was better for Munro basically because the cars he was testing had that characteristics. So slightly better, it became better. But when you test a car with a completely different characteristics, okay, then these statements may not make a meaning. So in other words, there is always a range in which the driver is going to feel good, okay, or in other words, his subjective evaluation is going to increase. Okay, this is a range, and maybe it's a range, or maybe it's a value where after a certain value, he is going to say it is better. Okay, right. So what this group did was to expand this 4, they wanted to make it 8, and so on, expand it. Okay. So there were a number of questions. I'm not going to go through this now, but there are a number of questions which actually correlated with memorometrics. Okay. Look at the paper. We will come back to this, but we will. So what these people did was to expand the metrics. Okay. Instead of 4, they started using. In my opinion, 4 is very good. The correlation has been good, but if you want a more a closer interaction with the subjective rating, then you can expand that metric. So for example, natural frequency, steady state gain of yaw velocity, phase delay at 1 Hertz is fine. Then they introduced also yaw rate gain at 0.7 Hertz. Road wheel steer gain, road wheel is steering wheel to road wheel. Okay, the road wheel steer gain at 1 Hertz. Lateral acceleration gain at 1 Hertz. The road wheel steering of the road wheel, okay, the face of this road wheel steer at 0.4 Hertz. Yaw at 0.4 Hertz. Okay. So these are the further metrics that was added as far as the frequency response is concerned. So they expanded the metrics. No more four guys who are going to form a rhombus. Okay. So numbers are increasing. They said these are the vehicle parameters which correlate with subjective rating. Okay. In other words, when the vehicle is driven straight, or when it takes a turn, when you brake during cornering, all those things are affected by these parameters. Okay. Apart from that, other further metrics are, we'll talk about TB characteristics at 0.2 G, TB characteristics at 0.6 G, peak steer velocity torque at 0.2 G. What is the velocity torque peak steer? TB is what is called as the defined as a product of the response time of the yaw velocity. It's quite involved. Okay, just read this. Defined as the product of the response time of the yaw velocity to the first peak, and the steady state slip angle. It's a product, and the steady state slip angle, okay, achieved from the J-turn test. Okay, things are becoming complex, right? So the numbers are increasing, right? Okay, so TB, which is a product of these two things, time and the slip angle at 0.2 G, when you take a turn or when you take a J-turn, okay, and when the acceleration is 0.2 G, what is TB characteristics? Then 0.6 G, which means that you increase the velocity and take a turn, so that the lateral acceleration that you achieved is 0.6 G. Peak steering wheel torque, okay, peak yaw rate at 0.2 G, peak roll rate response at 0.2 G, understeer parameter K, understeer gradient, steering torque at 0.3 G, then D slip by D lateral acceleration at 0.4 G. Okay. The next question is, oh God, list is becoming, okay, losing track. The next question is, it's not been answered, is why are we looking at these things? Okay, who told you, or what is the logic of suddenly coming and telling me that TB characteristics at 0.2 G or peak yaw rate at 0.2 G has a correlation with vehicle performance? We are saying that these things are important for vehicle performance. Okay, why is this at 0.2 G? Why is it that steering torque at 0.3 G is important? Why is it that you are looking suddenly at road wheel steer gain at 1 Hertz? Okay, and why is it that we are looking at other things like D slip angle by D, that's the slope of the slip angle to lateral acceleration at 0.4 G, taken at 0.4. Why are they important? Not clear.
Sir, but the basis for choosing these was from the statistical studies, right? They said
Correct. That's all. That's all. It is a question of curve fitting. When I have these parameters, when drivers answer a question, okay, number of questions, and when they agree, when I look at these two things, okay, looks like these are the parameters which are affecting. Okay, this is an open research yet. Why should it be at 0.6 G? Maybe different. Okay, so this is actually an open. Yes, it has a science because you look at some frequency response at these positions and so on. But I would say that still that it's an open thing. It may be. I mean, there's still a lot of scope to understand this. That's what makes one car different from the other. Okay, so the interesting point is this. We close this. Ultimately, we come up today's class with this. So ultimately, we come up with a range of objective metrics for good subjective rating. So in other words, if you want to design a car, and if you want this to be approved by expert drivers, hopefully the customers will follow the expert drivers. Then how do you design the car? That's the question, right? So I will design a car with a natural frequency of yaw velocity between 1.7 to 2.1 hertz. Okay, looks like if this is the range, people are happy, right? This is the range. That's what I said. This is a range. When the damping yaw ratio, damping ratio of yaw velocity is, no, I don't have that figure, but I'll get that. So steady state gain of yaw velocity 0.1 to is between 0.1 to 0.2 degrees per second per degree. Phase delay of lateral acceleration at 1 hertz is less than minus 75 degrees. Yaw rate gain at 0.7 hertz is between 0.2 to 0.25 degrees per second per degree. So you have, I'll just leave this, maybe next class we will again go through this. You see that each one of them has a range, a greater than or approximate values. Okay, so that's the importance of the study, that it gave a sort of numbers for designers. What should be your aim? Where should you stand if you want to get a good car whose handling characteristics are good? Okay, so that is the importance of the study. We will continue this in the next class. We'll look at questions and these things in the next class.